In this one semester course, we'll look at some of the key ideas that make 3D animation and game design possible. You've already done some things with this. In your high school algebra course, you learned about the Cartesian coordinate plane. You could worry about identifying any point in that plane. For example, there's the point 2, 4. If we went and associated with every point in this plane, we identified a color and a brightness, then we could draw any picture. That is indeed what a digital picture is. An idea that's even more powerful than the idea of points in the plane is the idea of vectors. A vector is something that has a direction and a magnitude. Here, this is the vector u. No matter where we place that vector, it's still the same vector because it has a direction and a magnitude. The interesting thing is that associated with every point in the plane, there's a vector that starts at the origin and goes to that particular point. So this vector u is identified with this point A. Vectors can capture the concept of points in the plane, but they do much more than that. That idea is extended to 3 dimensions. In this case, we're looking at this red dimension. We'll call that the x dimension, the y dimension, the green dimension, and the z dimension, the blue dimension. And so we could identify any point in 3-dimensional space by telling how far it needs to go in the x direction, how far it needs to go in the y direction, and then how far it needs to go in the z direction. So for example, here's the point 2, 3, 5. Came 2 in this direction, 3 in this direction, and 5 in this direction. And here's the vector associated with that point. It goes from 0, 0, 0 to A. So there we are, a vector and a point. Now once again, we could produce anything that we wanted in 3 dimensions by identifying which of the points are the points that are involved. In 2 dimensions, we were interested in describing lines. We had a number of equations for those lines. We will redefine lines and explain them in terms of vectors. We were interested in studying the situation where we'd have 2 lines, and in general, 2 lines would intersect each other at one particular point. So we were interested in finding where that point was. In 3 dimensions, we're interested in planes. Here is a plane. You can see it there from different angles and viewpoints. If 2 planes, in general, 2 planes are going to intersect in a line. So here's a second plane. You can see over here where those 2 planes intersect. They intersect in a line. So we'd also be interested in knowing where a line and a plane intersect. So if we had a 3rd plane here, then we'd be interested in seeing where that plane intersects this line that's the intersection of those 2 planes. We'll describe a lot of these things in terms of vectors. 3 non-collinear points determine a plane. So let's look at these 3 points and consider the plane that goes through them. So here are the 3 points. They're non-collinear. They form a triangle, and that triangle sits in this plane and determines that plane. We're going to be very interested in triangles because they're a basic building block of 3-dimensional objects. Here's a 3D monkey head. You'll notice that it's made up of a bunch of triangles that are attached to each other edge to edge. Look at the eyes here, for example. Triangles attached to triangles attached to triangles. Could build 3-dimensional objects with planes.